Oersted accidentally discovered that current can also produce magnetic field around it. And when he found that, he verified by keeping a magnetic compass at various positions, and he could see the deflection of the compass, which proved that yes, current carrying conductor is having magnetic effect. First topic in this chapter was properties of magnetic field lines, also called as magnetic lines of forces. And I gave you some 4 properties, all are very important. It is a frequently asked question in the board examination. The properties are, the first property is the line starting from north and going towards south externally and moving from south to north internally. The degree of closeness between the magnetic field lines talks about the strength of magnetic field. The more closer the lines, the more stronger the magnetic field. The more far the lines, more weaker is magnetic field. Third point is, tangent drawn to a magnetic field line gives the direction of magnetic field. It means you have a magnetic field line, draw a tangent. You understand at this point what is the direction of magnetic field. And the fourth point was, no two magnetic field lines can intersect each other, because if they intersect, it means that at same point we are having 2 different directions, which is not possible. So no 2 magnetic field lines will ever intersect each other. These are the 4 properties of magnetic field lines, very important for the board examination. When I talked about the experiments by Oersted, the first experiment was to find the magnetic field for a straight current carrying conductor. To find that, sometimes they will ask in the board exam, demonstrate by using an experiment how magnetic field for a straight current carrying conductor is found. In that case, in words, you should write properly about the whole experiment. What is that? A wire has to be taken. Rayan Ahmed, shall I put you in waiting room? A wire has to be taken, a cardboard has to be taken, a hole has to be made in the cardboard, the wire has to be passed from it, and filings have to be sprinkled on the board. When the wire is carrying a current, we have to tap the board. The iron filings will align themselves in concentric circles pattern, and direction of these concentric circles is found by right hand thumb rule, which says that if you hold a current carrying conductor in right hand with thumb pointing towards direction of current, the 4 fingers will point towards direction of magnetic field. If current is going like this, it will be anti-clockwise. Current going down, it will be clockwise. If you are talking about 2-dimensional system like in the plane, then if the current goes like this, it will be into the plane, out of the plane. All these things I have spent one whole class to teach you. So by now you should know how to determine the direction of magnetic field by using right hand thumb rule. So he also found that when direction of the polarity of the battery is changing, direction of magnetic field is changing. That is, when the current is going in the upward direction, he found magnetic field is anti-clockwise. When current was going into the plane, it was clockwise. These experiments were done by Oersted to find the pattern of magnetic field lines due to straight current carrying conductor. Pattern was concentric circles. And he also found that magnitude of magnetic field is depending upon 2 things. One is current flowing in the conductor. Second is distance of point from the conductor. More the current, more the magnetic field. Less the current, less the magnetic field. Directly proportional. Farther the point, lesser the magnetic field. Smaller the point, more the magnetic field. Inversely proportional. So magnetic field by straight current carrying conductor is directly proportional to current and inversely proportional to distance of the point where you are finding the magnetic field. This is the wire and you are finding the magnetic field near to it, it will have a greater value of magnetic field. If you go far, it will have weaker magnetic field here. These things are found by Oersted. Second was magnetic field to circular current carrying conductor, and for that experimental setup, he took a board, made 2 holes, passed a coil through it in a circular manner, spread iron filings, tapped the board. He saw the pattern on the board. It was like circles becoming straight parallel lines, and then he determined the direction of magnetic field. He also told that magnetic field pattern is like circle becoming straight line in the middle, and he said that magnetic field is depending upon 2 things. One is current, once again directly proportional, more current, more magnetic field, less current, less magnetic field. And second point was its radius. If the coil had a greater radius, it had a smaller magnetic field in center. If it had a smaller radius, it will have a greater magnetic field at center. So a smaller radius wire will have a bigger magnetic field in the center compared to a bigger radius wire if both are carrying same current. Direction of magnetic field is found by using same right hand rule. This time the four fingers will give current direction and thumb will give magnetic field direction. If current is going like clockwise, thumb will is pointing into the plane, magnetic field is into the plane. If current is going anti-clockwise, thumb is going towards you, the magnetic field is out of the plane. Then we have found what is the magnetic field due to a current carrying solenoid. First of all, what is a solenoid? Solenoid is a device. Yes, it is a insulated copper wire wound in cylindrical form. Take copper wire, wound in cylindrical form, you get something called as solenoid. It has multiple turns. The beauty of solenoid is it behaves same like a bar magnet. How the magnetic field lines of a bar magnet, same way this solenoid has magnetic field. So you can draw the pattern. Pattern of magnetic field by solenoid is very important. Sometimes they may ask you, what are the ways to increase the magnetic field of the solenoid? There are multiple ways, 3 ways are there. I said you already, magnetic field depends upon 3 things. One is current, second is number of turns per unit length, and third is the medium inside the solenoid. So if you want to increase the magnetic field, increase the current. It will have greater magnetic field. Second way is increase the number of turns per unit length, not number of turns alone, number of turns per unit length. And third point is insert some soft iron inside it. If you put a soft iron inside a solenoid, it becomes temporarily magnetized. If you insert steel or hard iron inside solenoid, it becomes permanently magnetized. So suppose you want to make magnets, insert steel inside it. Steel will become magnet, permanently magnetized. If you want to increase the magnetic field of solenoid, insert soft iron. It will give temporary magnetism to it. It will give magnetism for a limited period of time, only till the current is passing through it. Where are solenoids used? It is used in MCBs, electrical bells, and many other electric applications is used. I have talked about that in the previous classes. Last class, I spent my whole time on teaching you what is the force on a current carrying conductor kept in magnetic field, where I said you, if a current carrying conductor is kept in a magnetic field, it will experience a force because there is interaction of 2 magnetic fields. One magnetic field is the existing magnetic field, and second magnetic field is the magnetic field produced by current carrying conductor. Direction of this is given by Fleming's left hand rule. Definitely a question is going to come from here. Numerical is going to come from here. So have it very clearly in your head how left hand rule behaves. I said you, if you stretch your first finger, middle finger and thumb mutually perpendicular to each other, first finger giving direction of magnetic field, middle finger giving direction of current, then thumb will give direction of force. And the very common kind of question that is coming in the board exam is based upon the charges, not the wires. They may say charge is moving from right to left, left to right, top to bottom, bottom to top, into, out, anything they may say you. They may give direction of charge, they may give direction of magnetic field, and they will ask you to find the direction of force. I said it to you already, direction of movement of positive charge gives the current in the same direction, direction of movement of negative charge gives the current in the opposite direction. Find current direction, find magnetic field direction, put these 2 fingers, wherever thumb is pointing, that is direction of force. It will reflect right, left, up, down, whatever we have discussed in the previous class. Again, last class we spent a good amount of time to understand this concept of force on a current carrying conductor kept in a magnetic field. Today, as I said, we are in the last topic of the chapter, and last topic of the chapter is domestic electrical circuit. Shall we start that? So give the heading as domestic electric circuit. So before I even start talking about this, I'll tell you how is the question coming from this topic. What happened? Shall I give some notebook to you? Paper. Why? Notebook is not there. Carrying some 5-6 kg bag, 10 kg bag maybe, with no notebook. So in your bag there is no notebook. Who is helping you? Kamalesh? You already teared man page, I think. Huh? Give it to him. Since you teared, you give it one. Why? Tear in a way that it will not affect you. Coming for badminton class, no? Coming for class means you should carry some notebook, man. If you know today you're going to not come on time, then you should have carried in from your home itself. Whatever. Come back. I said you, let me tell you first from where the questions are going to be asked in the board exam from this topic. There are three very, very famous questions. One question is about the application of earth in. Second question is about overloading of current. And third question is about short circuiting. Short circuit. And sometimes they may ask a question from fuse also. These are the very famous questions that are being asked in the board examination from this topic. Either of all these questions will come in the board examination. Okay, before I talk to you exactly how the question comes, let me explain you about this. In this topic, we are going to learn, if I am right, somewhere I remember I have taught this topic to you already. I don't know why I taught that. Someday I taught this topic. Once again, I am repeating it. Someday I taught this. We are repeating once again, no problem in that. So, this topic teaches us how our domestic circuit is made. That is, in your home, current comes, power comes, isn't it? The power comes, in everybody of your home, you will have a main board. Main board in the sense, I am talking about the place where you have the meter. Below the meter, you will have a fuse, that ceramic fuse, where if they take out, you will have a wire inside, copper wire. So, if you are living in an apartment, it will be somewhere down, or if otherwise it will be somewhere inside your home. But there is a place where you have a meter box. Every home should have that. If not, then you are not paying the bill. There is a meter box. Meter box is the place where the current comes to your home, it comes inside your home. So this is the first point where the current is entering inside your home, coming at 230 volts, 50 hertz. So what voltage we are getting in our home is 230 volt or 220 volts, whatever. 230 volts they will say, 220 also you can take. And what is the frequency at which Indians are getting current is 50 hertz. So we get current at 220 volts or 230 volts, 50 hertz supply. When it comes inside, let me open the NCERT diagram itself. Why to draw my own diagram? In exam you should draw the same thing. What is this? Nothing came for writing. Which class is this? Structure of atom. Class 10, science. What is the chapter here? Number 14. What is not there? 12. 12. Not knowing. You are having book, man. Number, man. 12, you know? Yeah, I'm right. Okay. Sorry. What is this, brother? Okay. Let me come directly to the last part. Yes, I am talking exactly about this. This is what your connection should look like. Ryan, man, every time if you make me to say to on your cameras, definitely I am going to put you in waiting room. So as I said you, the first point where the current comes to your home is the main board. This is electricity board, which has a fuse. And they have drawn it separately, but it is actually the same place where Indians, we have same place, the main board and the meter. So if you see, there are three different colors of wire. The green one is earth wire, The red one is called as live wire and the black one is called as neutral wire. I don't know how, but many of us generally make a perception that if I have a point like a plug where we are putting the, I mean, the, the port, we have 3 holes there, isn't it? We have like this 3 holes. We always assume that one is positive, one is negative. Many of you think like that. Should actually. But it is not positive, negative. It's not a battery. Battery will have terminals like positive and negative. Positive is at higher potential, negative is at lower potential, all these things. But in alternating current supply, we rather have a live wire point and a neutral wire point. What is the meaning of that? Live wire is the wire which has the potential. That is, if you are having 230 volt supply, live wire has how much volts? 230 volts. And neutral wire has 0 volts. When I say that potential difference that you are getting at your home is 230 volt, how this 230 volt is created? By maintaining live wire as 230 and neutral wire at 0 volt. So all the power, it comes in neutral wire only, remember that. Sorry, live wire only. Neutral wire is just to create the potential difference of 230 volt. If I make neutral wire to be at 100 volt, it will become potential difference of 130 volt, isn't it? 230 minus 100. But if I maintain neutral wire at 0 volt, the potential difference will be remain 230 volts. So live wire and neutral wire are entering inside. Then we have this distribution box. Usually in every home you will have a box where you will have all the MCBs. Have you seen it? Based upon the home how we have made, you will have many MCB. Here also there are MCB boxes there, which is the half opened. If I open that fully, inside you will have many MCBs, blue color MCBs will be there. By which if I put it down, this room current will go. There are many small switches. If I off one, some light may go. Second, some other light may go. Third, some other light may go. Like that, this buildings, this rooms, connections are there in that distribution box. So in distribution box, we decide what kind of current we are going to supply to your home. That is, we can make some points of 5 ampere, we can make some points of 15 ampere or 20 ampere also. That is purely based upon your demand. Suppose you are going to say, in my home I want all 3 rooms AC connection. Then they have to give 20 ampere point in all the 3 rooms. Suppose you specify, no, in my 3 BHK home, in 1 room I don't want AC point. I want in 2 rooms I want AC point. Then where you don't want AC point, there they will give 5 ampere, other place they will give 20 ampere. So based upon your demand, how much you are going to use, they are going to give you that kind of current rating. Generally nowadays, everybody is getting 20 ampere rating everywhere. So if you see clearly here, you will realize that we have 3 points mentioned here, and all 3 points are in parallel connection. Can you see that? They are in parallel connection. The neutral is common to all, live is going above, and the earth also is going here. I'll talk about earth as the last, but just concentrate on red and black lines. So this and this, the 3 plugs given here are having parallel connection. Now why do we go for parallel connection? Why not series connection? There are 2 reasons for that. First reason is to maintain the same potential across each line. See, if you have 3 rooms, I cannot give in 1 room 200 volt, in 1 room only 100 volt. Because whatever appliance you have, all the appliance at your home is designed to work at 220 volt. Whether it is a small appliance like mobile charger, or a big appliance like AC, or an appliance like TV, or an appliance like fan or light. Every appliance in your home works at 230 volt. It is designed to work. If you ask me, sir, what if I give only 100 volt? I will not give 230 volt. Will it work? It will work. Suppose this is a TV in front of you. This TV is designed to work at 230 volt. But I give only 110 volt. Will the TV work? It will still work. What is the problem, you know? Since potential is less, current will become high. You know, V is equal to IR, that is, we will say V proportional to I. You may think like if you have more V, you have more I. But here we're not talking about that. Here we're talking about the power consumption. Power is equal to V into I. Remember from the previous chapter? P is equal to VI. You remember the formula or not? Power is equal to voltage into current. How it has come? Work done by time, and work done is equal to V by Q, V into Q. So V into Q by T is I. So V into I. So power is VI. From here you can say P is equal to VI. So V is equal to P by I. So V and I are inversely proportional when the power is being consumed. Remember this. Don't apply Ohm's law and think that less potential, less current, more potential, more current. It's not like that. We are talking about power consumption here. So whenever the power is consumed, current and voltage are inversely proportional. So what happens? If I give low voltage, it will have high current. And if it has high current, the current creates heating effect. Heating effect means it will become hotter. If it becomes more hot, it may catch fire also. I told this in the past, once again I am repeating. Indian trains are designed for 110 volt supply. Actually, once upon a time it had 220 volt, some 15 years back. But because a lot of thefts and many cases in the Indian railways, they changed to 220, 110 volts. Because you know our people, they will think it is public property and they will take it to their home. They do like that. Train is running, train we have fans, light, oh fan, open and take to my home. It happened once upon a time, happened severely. So they will travel with family and they will take a light fan from there and come back to home. And then when the train will go for audit, there is no light fan. Big problem that once upon a time. And they'll use for their home. What is there in that? Public property means my property. They'll take it to their home. So how the government fought with this problem? They cannot put police in each cabin, right, for that. Because that itself will be expensive, then for that they'll lose a fan itself. So what they did, they changed all the appliance of trains and designed it to work at 110 volts. Good, smart move actually. And they started giving in the train 110 volt supply. Now what fan they are using in train, what light they are using in train, what point they are having in train, everything is having how much volts? 110 volts. So if you take it also, you cannot use it in your home for a longer time. It will go off in a few days. Second thing is, if you have traveled recently in train, then you will notice that if you try to charge your phone there, the phone will become hotter. If you charge your phone, laptops in the train, the phone will become hot soon. Why is it becoming hot? Because the voltage is low, it is taking more current from there. Since it is taking more current from there, it is getting heating effect of electric current. Sometimes in home also, your phone will become hot while charging. If your phone is becoming hot while charging, one reason can be the problem in the device, or second reason can be low voltage. If voltage coming to your phone is going to be low, it is going to have more current and it is going to get heated. Coming back. So, as I said, the parallel connection in the domestic supply is given because they want to maintain same potential difference. Second benefit of having parallel connection is, if one thing stops working, other things are not affected. You know very well how a series connection works. If you have bulb here and bulb here and bulb here, if this bulb fuses, what will happen? Current will not be able to go in any bulb. All bulbs will be off. But if you have bulbs like this, bulb here, one thing stops working, other will still work. So that's why we give parallel connection. Are you getting? So two reasons of giving parallel connection. One is to maintain same potential difference across each appliance. Second reason is to make sure that if one device stops working, it does not affect the other devices. Is it clear to you? That is the reason for having parallel connection. Now talking about the earth. Sometimes what happens, when you are having an appliance, then there is a possibility of overloading of current. You know what overloading is? Any idea about overloading? This term overloading. I wrote on the board before the class starting today that overloading is an important topic in this chapter. See, overloading happens when neutral wire and live wire come in direct contact. To understand this once again deeply, the conceptual level, when you have potential difference and you join both, what will happen? Current will flow, isn't it? There is a potential. Suppose I put a wire in one point, another wire in one point, and these both wires I join here. What will happen? Current will flow in that, isn't it? If the current is flowing, the current must pass through some resistor. For example, if I'm having AC there working, AC is connected to some point. Okay. Now AC is having lot of resistance, and that's how the current is consumed. Are you getting my point? If I have put the point of TV in the plug, the TV has lot of resistance, and that resistance of TV is only consuming the power. When I connect two wires directly, there is no resistance, sudden surge of current happens because current is not being consumed by anything, and that creates overloading of current. It may happen by many reasons. Suppose a wire became old, it became naked, but the plastic insulation came out. It may can't touch. If two live, that is one live, one neutral wire touches directly, no, that's all. Overloading. Overloading means excess current came. Excess current leads to short circuiting. See the word itself, short circuit, from where it came. Circuit became short. Circuit needs a resistance at least. If that also is not there, circuit has become short, and that's why it is called as short circuiting. So short circuiting and overloading are related to each other. Because of short circuiting, overloading takes place, or basically overloading happens, then short circuit happens. And if that happens, then it can lead to big disasters also. You can see many examples of the old buildings that has been burnt by fire accidents, electrical fire. How it happened? Short circuiting. So in order to avoid that, whenever excess current comes because of overloading, what we should do with it? Somehow send it to earth. For that reason only, what we have? We have earth wire. So why is earth wire given? Earth wire is given for safety purpose. What is the purpose? If excess current comes by overloading, if it comes, the earth wire will take that current where? To the earth. Why it is called as earth wire? You know, when you make a building, then all the top points, that is the earth points, they are together connected, and they'll while making itself in the construction process, they will make a hole at least 2 feet deep, minimum 2 feet deep hole. In that hole, they'll keep a copper plate. Then they will put some salt on that. They'll connect some wire, and then they'll join it to the earth wire, so that whatever current comes, it directly goes inside the earth. A good conductor they make. Salt because of having its property of ionizing. So they make sure that they always have the possibility of the excess current to go inside the earth. That's how they give earth. Some place I have also seen in our Indian, again, countries like India, they don't bother much. They will give all place earth points, but they won't connect it to the ground. There is no use of earth point. You may think I am putting something inside working, nothing will happen. If earth points are not connected and given back to the earth for taking it back, then there is no use of earth point. But I have seen it happens in many places. Anyhow, coming back. One more important thing, not there in the book, but I am telling you. If you see the connection, the plugs, usually the earth plug will be longer than neutral and live. I have told about this already. Have you noticed it? Wherever you see 3-plug system, 3-pin system, see many things will not have 3-pin itself, like mobile charger will not have 3-pin generally. Why? It is not taking much current. It is not taking much current. Why we want to bother about overloading? So they will give only live and neutral. They won't give earth connection itself. But if you see this kind of huge appliances, AC you see, TV you see, this kind of lights you see, laptops, charger you see sometimes, which consumes more current will have 3 points. And if it is 3 point, the topmost point will be broader and longer. You know why? Because when you are inserting in that switch junction box, earth should touch the metal first. Are you getting my point? If it is longer, then it will go and touch first, right? If excess current is there, it will go first down to the earth, saving your appliance from having some problem. If all are having same length, all three will go together. By the time earth is realizing that excess current is there, it will also go in the live and neutral wire, right? To safeguard that, they are having a longer earth point, because if earth is longer, it will connect to the socket first, and if excess current is there, it will take it back to the earth. I hope it is clear to you. So this is how our domestic circuit is made, where we have earth wire used for safety purpose, live wire having 230 volt, neutral wire having 0 volt. All the rooms in the, all the appliances in the home are under parallel connection to maintain same potential difference, and if one appliance stops working, it won't affect the other appliances. And we are having fuse in the main board itself in series connection. Fuse cannot be in parallel, common sense. When the current is coming inside the building, and if excess current comes, what will fuse do? It will melt. If it melts, it will save all the device from getting some problem. So if excess current comes in the entry point, here itself they told, no, electricity boards fuse. Because what is the meaning of fuse? Just a wire. Fuse having a wire. Which wire generally used for fuse? Nichrome wire. What is it? Tungsten. Nichrome is used for fuse, because nichrome is an alloy which has low melting point and high resistance. Never forget this. Fuse means low melting point, high resistance. Why high resistance? Because the current should pass slowly through it. Why low melting point? If it is having excess current, it should melt. If it melts, it should break the circuit and safeguard the other appliances. Are you getting my point? So at the entry point itself, one fuse will be kept. This fuse will be used for what? Safeguarding all the equipment. And then we have electricity meter, where all the readings comes for the power consumption, and a distribution system. And then we have all these appliances connected in parallel. Is it clear? Yeah. If there is 5 socket, we have 2 live and 2 neutral. Because see, sometimes some appliances are made which have less distance between the live and neutral. They are put in the above point. We are having 3-point system, no? They are only put in the bottom. Sometimes for bottom also we can put the 2 things. So it all depends upon the manufacturers. And sometimes people will come from other countries, and they have a different socket system. If you go to America, they'll have flat pin system. So we'll have some conversion units for converting it to round pins. If you go to Europe countries, some American countries, they don't use round system itself, they have flat pin system. So we have to convert it, the flat pin, into round pin. These things are there. But why we have 5 is, we are giving 2 live and 2 neutral, 1 earth. So suppose your pin is having closeness between the live and the neutral point, you can put in the small one. If it is 3-point system, you can put in the bottom one. That's why they're giving. Both are same only, but okay. And one thing, whatever I have spoken, this 3 color system is there, no? Green, red, and black. It is for single phase connection. If you open the board, you may see yellow color, blue color. Never learned in school. They told me only about green, red, and black. But I am seeing yellow and blue also. Yellow, blue color wires, if you are able to see, it means it is 3-phase system. What is the meaning of 3-phase? 3-phase means live current will be coming from 3 different wires. Why we are having that? Suppose your power consumption is more, and you want to have less power cuts, then you will take 3 lines. If one phase goes, other 2 may be there. If 2 goes, 1 may be there. All 3 goes, your bad luck. But why we are having 3-phase? Because you have 3 possibilities of current. Like this building has 3 phase. If one phase goes, other phase will be there. Have you seen in your box also, it will be there, a switcher will be there. 1, 2, 3 will be there. So wherever you want, you can choose the phase. If some phase goes, some other phase may be there. That's why we are using 3-phase system. So nowadays many homes are having 3-phase. So you may not be having only these 3 colors. You may have 5 colors. Apart from red, green, and black, you may have yellow and blue also. If yellow and blue are there, they are also live wires of 2 different phases. Is it clear to you? Otherwise, generally these three only: green, red, and black. If it is clear to you, then we are towards the end of this chapter, and I'll show some questions how it is being asked from here. But is it clear to you how the questions will be asked? I told you, overloading. What will you write? What will you write for overloading? If live and neutral wire comes in direct contact, then excess current flows inside a circuit. That is known as overloading of current. If they ask you define short circuiting, once again you can write when live and neutral wire comes in contact due to overloading, the circuit becomes short and excess of current flows inside the circuit. This is known as short circuiting. If they ask you about the role of earth wire in the circuit, it is used for safety purpose. Whenever excess current comes in circuit, it is used to take it back to the earth. If they ask you why are we having parallel connection, to maintain same potential difference across all the appliances and to make sure that appliances work even if other appliance stops working. If they ask you what is the nature of fuse wire should have low melting point and high resistance. Which wire is used for fuse wire? Nichrome is used, alloy of nickel and chromium. Okay, so like that questions can be asked in the board exam from this topic. Is it clear to you? If yes, then let us see how are the questions given in this chapter. So see, if you see here, name two safety measures commonly used in electric circuits and appliances. Tell me. Fuse, correct. Earth, isn't it? Fuse and earth. Next question you see. Next question numerical. Everybody try this question. Electric oven of 2 kilowatt power rating is operated in a domestic electrical circuit 220 volt, has a current rating of 5 ampere. What result do you expect? Explain. Tell me the answer for this question. Everybody please try. Simple question. Yeah. Switch off. I'll reduce the fan speed and temperature. AC remote. Got the answer? Try to solve, guys. Question number 2. Question says electric oven 2 kilowatt power rating. 2000 watt. What result do you expect?
Sir,
Till
the electric oven will get damaged because there is excess current due to overloading.
overloading. Why?
Sir, because if 220 volt is passed to 2 kilowatt power rating, the electric oven, sir, the current required is 9.909 amperes.
Okay, but the current rating is only 5 ampere. What will happen then?
Sir, then overloading will happen.
Okay, what do you see, Nitin? See, power is 2000 watt. Okay, Daksha. And the voltage is 220 volt. The formula is, I told you for some time, P is equal to VI. I will become P by V. P is 2000, V is 220. When you solve it, you will get around 10, 9 point something. Around 9 point something ampere, 10 amperes we will take. 10 ampere current is drawn. And what is the rating, current rating? 5 ampere. What will happen? It is having more current than the rating of the circuit. It will draw excess current and it may fire up. Overloading of current may take place and it may lead to fire accident. Electrical fire. Is it clear? How I found the answer? I was having power value. Power is how much? 2000 watts. I am having voltage value. How much? 220 volts. I have the formula P is equal to VI. I will become equal to P by V. Solve, you will get how much you are getting? 9.09 amperes. If it is 9.09 amperes, it is greater than the rating, current rating of 5 ampere, which will lead to overloading of current. Correct. Question number 3, you see, what precaution should be taken to avoid overloading of domestic circuits? Using of MCBs, okay, fine. Using of earth wires, fine. What else? Loudly. Loudly, man. Limited amount of what? That you cannot limit here. I will not use AC, can you say? I will not use heater. That is not the option. Regular check of what? That is not for overloading. Proper insulation, okay, yeah. The wire should be insulated. As you are saying, same thing only. We check whether it is insulated or not. Moreover, what other precautions you should take is always using the points based upon the current rating. Suppose it is a 5 ampere line, I cannot put AC in that. AC will definitely consume around 15-16 amperes. So I should use a 20 ampere point here. The rating should be 20 ampere. So you should always use the appliance in the correct current rating. If current rating is low, we should not use more power consuming device there. Same 5 ampere point, if I connect mobile charger, no problem. If I connect laptop charger, also no problem. If I connect TV, there is no problem. Light, there is no problem. Fan, there is no problem. But if you connect 2000 watt oven, definitely big problem. If you connect 4000 watt big AC, definitely a problem. Are you getting the problem? What I said now? Overloading takes place if you connect a high power rating appliance in a low current rating switch board. So every switch board will have a rating. For example, if you see here, it will be written there. See, 20 ampere written. It means this switch is 20 ampere capable. You see there 20 ampere written. Every switch nowadays will come, not old. That old switch will not have. But new switch nowadays will always have a rating written on it. 20 ampere or 5 ampere. If it is 20 ampere, there is no problem. If it is 5 ampere, you should use less power devices there. What happened, Kanishka? That is AC point. It will have written actually. You see properly, 20 ampere will be written. Huh? 20 will be written there, yes. Coming back. So basically, we are done. Revan sir, you can stop the meeting. Meeting in the sense that live.